So this is a topic that is section 16.3 in the book. It's about complex ions. This is really if you plan on taking the AP test. So this is on pages 774 in the book. So I'm just going to give up the straight up definition. So a complex ion is a charged species surrounded by a ligand. All right? And what's a ligand? A ligand is a Lewis base. A Lewis base, remember, donates a pair of electrons. Now, they're not going to ask you to straight up identify a Lewis base, but you really can't explain what a complex ion is without understanding what a Lewis base is. But when you're in college, they're going to talk about Lewis bases a lot, so it's not going to hurt you to learn it now, okay? So if we go back to our oxygen lab, percent of oxygen lab, where we calculated the percent of oxygen in the air, we took, and you can go back and look at your lab, we took cobalt chloride and we put it in water. And this thing dissolved in water, okay, right? Because because chlorides dissolve in water, that's why, except for the four silver, lead, mercury, and copper 1. And then what happened is the cobalt 2 plus formed a complex ion. What happened was water, with its lone pair of electrons, formed a weak bond with the cobalt. And 6 of them did this. Now, how many that do that, kind of depends on the metal. But in all cases, the oxygen was donating a lone pair of electrons to form that bond. So the complex ion would be cobalt there you go, there's the complex ion, that's the ligand, okay? And then we added ammonia to this, concentrated ammonia, and what happened was, I'm writing water like this. When we added the ammonia began to replace these. Now, why would ammonia replace the waters? Well, ammonia also acts as a Lewis base. It's donating a lone pair of electrons. So when we did this lab, we added enough concentrated ammonia that it replaced approximately 5 of the I think if you actually look in the lab shows that this one remained as water. It doesn't really matter, but I just want to be consistent with the lab in case you go back and look at the lab. So here's a different complex ion, cobalt, 6 ammonias, OH2, let's write it as H2O. Okay, big old brackets, +2. Why is it a +2 charge? Because cobalt has a +2 charge, and the ammonia that you're adding is neutral, and the water that you're adding is neutral. Okay, if you were adding something that had a charge, it would affect the charge on your complex ion. Okay, so this sort of stuff happens when you add concentrated ammonia, and this sort of stuff happens when you add concentrated base. It doesn't matter which base. It could be lithium hydroxide, could be sodium hydroxide, could be potassium hydroxide. Okay, I'm just going to give you one example of this. For example, if we add sodium hydroxide to aluminum, what you get is aluminum hydroxide, which is a solid, plus sodium ions. I'm going to rewrite this because I ran out of room and I feel upset with myself. So the aluminum reacts with the sodium hydroxide. We get aluminum hydroxide and sodium ions. Okay, I'm going to balance this just for the fun of it. All right. Now, is aluminum hydroxide precipitate? Yes, it is. Okay. Which hydroxides are not? The strong bases are aqueous, right? All strong bases break apart 100%. All other hydroxides do not. However, so like for example, sodium hydroxide is aqueous, right? However, if we continue to add strong base, okay, strong concentrated sodium hydroxide, what can happen is you can form the complex ion, okay, like that. So here's one where it was neutral and then another one came on there, another hydroxide. Hydroxide carries with it a negative charge, and that's why it ended up being negative. And this dissolves, that's aqueous. So when you add concentrated base to aluminum, it first precipitates as a white solid, and then it becomes aluminum tetrahydroxide, which is aqueous and disappears again. So again, this is really sort of the stuff they're going to ask you on the AP test as far as solubility goes. They may or may not ask you to calculate KSP this year just because they're only asking 2 questions.